Have you ever wondered about the future? And what sort of amazing things might be around in 5, 10, 50 years? Hi, I'm Steve, and some of the most amazing advances could be right here, in the palm of my hand. Hundreds of them, in fact, all too small to see because we're talking nanotechnology. And that means very, very, very small technology. As Adam Spencer says, let's say every step you took was a nanometer. It would take you a day to walk across a human hair. A lot of smart people are betting that super small things could be the next big thing. And today we're going to hear from some of them. In this program, 12 people will talk about what they're doing today and share their ideas of some of the most exciting developments that may shape our future. First up, Dr. Peter Binks, the Director of Nanotechnology Victoria, talks about textiles that turn into wearable technology and science fiction turning into science fact. Doctor Who? No. Dr. Peter Binks.
I've been with Nanotechnology Victoria for about 3 years now, since the start-up of the company. I feel privileged to have that opportunity. This is a new venture formed by the Victorian Government and a consortium of universities. And our whole purpose is to try and commercialise the nanotechnologies that are coming out of our academic institutions. It's a really exciting opportunity. There's a whole lot of really interesting technologies coming out now. There's real demand coming from Victorian and Australian companies. People are starting to get a sense of what nanotechnology can do. And we're right at the cusp of that. We're trying to form a company that will take this stuff through to market. The thing about nanotechnology is, A, it's new, and there's a whole new sense about it that we can do some remarkable things we couldn't do before. The second thing is it's multidisciplinary. You're no longer just a physicist or no longer just a biologist. And nanotechnologist is someone who combines all those disciplines in together, because you're developing materials that have got new physical properties, they react chemically in very different ways, they incorporate biological mechanisms, which are some of the most efficient that we know. So there's a whole lot of exciting new things happening around there. My own view is that the textiles industry will be one of the early adopters of nanotechnology and is already starting to introduce nanotechnology-based products. Textiles have changed dramatically over the last 20 years. They're no longer just materials like this which have a particular shape, a certain kind of limited functionality and colours, etc. They're now becoming really dynamic materials, and that ranges from protective materials like are used for mountaineering or sporting applications or defence and security applications, to textiles they're used in bandages and coverings and all of those kind of things for medical purposes. And what we're seeing is there's a whole host of companies that are developing these new applications, and they're based on global technologies, they're based on things that you can see coming out of the US and China in new materials that are now being incorporated into weaves like this. They range from things like light-emitting polymers, so you can actually make a textile glow or emit energy in some way, to hydrophobic materials, so ones that will shed water, to ones that can change their physical shape. So you think of someone who's climbing, say, Everest, and they're exposed to extreme temperatures, they're oxygen deprived, they may actually go into shock without realising it. So they can get to a circumstance where their core body temperature drops, where they're no longer receiving enough oxygen for their brain to function properly. So we're trying to develop materials which can potentially be used to signal that there's something wrong, or can actually take some therapeutic action. So a textile that could actually start to add extra heat, or could even start to move the body parts around a little bit to improve the circulation, or send a signal back to say to the guy, look, you know, you've got a member of the party who's distressed. Now those technologies exist now. You can do all of those kind of things. They've not yet been integrated in a commercial sense into the kind of garments that are used by security people or mountaineers or sportsmen. If you think about a modern soldier actually almost has to be a kind of unit in himself. He's got to have some materials around him that protect him. He's got to be able to fight, so he's got to be able to carry weaponry. He's got to be able to signal. They have enormous communications capacity, you know, with every single soldier. They use a lot of energy devices now. What that really means is your modern soldier is actually cluttered up with a whole lot of gear. They're carrying 50 to 60 kilos of gear into battle and often having to travel a long way before they can even get to use it. What we're trying to do is to develop new generations of materials that incorporate a lot of that functionality without adding weight. Michael Crichton's novel Prey is quite a chilling scenario of the future in which you have swarms of nanobots that can potentially generate their own energy and move around and even have a kind of group intelligence. Now that's an interesting scenario, but it's not one that's available within the next 10 to 20 years. We simply don't have the technologies to put all of that kind of power down on a very small particle and give it the ability to move and the ability to absorb energy and stuff like that. It illustrates to people that there are some incredible powers that are available in this new field, but also there's some dangers. There's some things that we need to manage properly as a society. The space elevator is a beautiful concept which actually changes the whole paradigm. It says let's have a ribbon or a cable that goes all the way up to somewhere in space that's made of some extraordinary material, and this is where the nanotechnology comes in, because you need a material that is both light and incredibly strong, that can tether a space station to Earth. Once you've got that tethering in place, you can ride that tether. You can actually send things up and down there like an elevator car or like an escalator, and you can change the whole energy paradigm. You no longer need to blast things up there, you can pull them up there, or you can supply energy at each stage along the way. You can supply it with having laser beams from underneath that can allow you to convert energy at each stage on the way.
Well, the space elevator would make the best theme park ride look pretty tame. Imagine a lift into orbit. But solar radiation is a problem for people in space and down here on Earth too. Next, Brian Innes, the Business Development Manager of Advanced Nanotechnology, tells us how nanotechnology has helped make things like a white sunblock become clear and how it could turn your windows into power generators.
So with business development, my role is to speak to the scientists, find out what's happening, try and understand the market and where it can go and bring the two together. So I need to have a good knowledge of the science and a good knowledge of marketing and business concepts. I hold a materials engineering degree, which gives me my inorganic chemistry and physics background, and I also have a degree in commerce, in marketing and human resource management. Surprisingly, one of the biggest nanotechnology inventors at the moment is L'Oreal, which currently holds more nanotechnology patents than any other company in the world. And the cosmetic industry is driving a lot of the science behind nanotechnology, and it's one of the areas we're currently involved in. Some of the products we're selling at the moment is a transparent zinc oxide, which we can, by controlling the particle very, very precisely, we can make zinc oxide transparent. This allows us to get the UV absorption properties of zinc oxide, which we know from using white zinc cream down the beach, but still make it transparent in a sunscreen. Our ingredient, known as Zinc Clear, is now being sold into a number of sunscreen products, and it's been used by brands on the shelves at the moment like Megan Gale, UV Natural, and also the Australian Cancer Council's got a product which is incorporating Zinc Clear. Anything which is susceptible to UV damage, so your skin is the most susceptible, the second is wood. So by putting it into wood coatings and varnishes, we can now get longer life wood coatings because it's the wood which gets attacked and not the coating. By incorporating nano catalysts into our fuels, we can get more fuel efficiency. By creating nano solar cells, we can start to get transparent solar cells, so every window can be an energy generator. By incorporating nano structures into our fuel cell materials, we can now make energy where the only byproduct is water. And by incorporating all this nanotechnology, nano precision, we can start creating the technologies which are going to drive the world to a much greener and cleaner place. Salaries are a function of supply and demand. At the moment there's an undersupply in good quality science graduates, and science graduates, they also have the interest and the abilities to speak marketing language and business language are rare as hen's teeth. So with limited supply and there's a lot of demand in nanotechnology at the moment, you can do quite well.
Imagine a car that produces pure water. You could pipe the exhaust into a sipper. I wonder if French cars would make Evian. But what about nanotechnology and human bodies? There are lots of small things inside us that nanotechnology could help. Here's Professor Gordon Wallace, the Director of the Intelligent Polymer Research Institute, with the inside story.
The most exciting thing as a scientist is not knowing what we're going to discover. I mean, we stumble into the area of nanotechnology, and we've already seen some incredible properties of materials that you just could not predict from traditional theory. So You know, it's almost like discovering new materials every day. It's like discovering a new copper or a new gold. Even though it's the same composition, by changing the size and the dimensions of these structures, we get totally different properties. And that's incredibly exciting for a scientist to think that you can make incredible discoveries like that on a weekly or a monthly basis. We're looking at building electronic components that are so small that they can perform very powerful functions, but also are easily integrated into an electronic textile. So that really makes the whole area of electronic textiles possible in the future. It's breakthroughs in nanotechnology that start to spread up a whole range of new areas that just weren't predicted previously. We've been very interested in making new fibres based on carbon nanotubes. We take carbon nanotube dispersions and we can coagulate them in a spinning beaker to form a very strong fibre. Now, some of those fibres can have tensile strengths similar to spider silk, which are some of the best known or strongest fibres known. These fibres, because of their nanostructure, take on very useful properties. They have very good electronic conductivity, which means you can inject charge into them and out of them very readily. They also can incorporate bioactive molecules, drugs for example, or nerve growth promoters. And as we stimulate that fibre with these small electrical charges, we can release that growth factor or that drug for particular applications. Now, we're particularly interested in nerve growth regeneration, for example. So we would be putting nerve growth factors into those fibres, stimulating them when we needed to release that, so that we could control the adhesion of a nerve cell, say, to the fibre, and then control the direction that cell grows in. Some of these polymers that we work with, it's very difficult to integrate them into other structures if they are conventionally sized particles. As we get them to nanoparticles, we can fully integrate them into other materials and make them into usable devices. And the knee sleeve example is a good one for that, because there you see a black strip which has got the polymer integrated into, it's just a conventional nylon lycra. And as we get the polymer in there, we induce electronic properties which enables it to beep in response to stretching or in response to knee angle. And so we have a project with Dr. Tim Scott at the North Shore Hospital in Sydney where we're looking at putting rehabilitation artificial muscle fibres onto a glove which can facilitate hand movement for rehabilitation purposes after major hand injury or surgery.